Section 8.4 is on parabolas. Parabolas are also, they're our last conic section. So we've done the ellipse equations, the hyperbola equations. We've done the circles, and now we're going to do the last one, which is parabolas. Okay, this is the strangest one. It's a little bit different. Yes?
Can I turn off one of the lights?
Yes, you may. All right, so you have this lovely picture in your notes, and it shows a line called the directrix and a dot called the focus. So I'm going to try to sketch this out to the side so you guys know what I'm talking about. So basically, if I have some kind of point, and I have a line called a directrix, there's really no nice way to do this with strings, so I'm going to try to, I guess maybe there would be, I don't know. If I want to divide this line into two equal pieces, that's going to be where my vertex is, okay? And then if I want to connect, so if I want to go out here and then straight down, and let's say those are the same length, that's going to be another point on my parabola. And if I go out here and I go down here and these are the same lengths, this will be another point on our parabola. And then up here and down here and these are the same lengths. Do you see what I'm doing? That's going to be another point on our parabola. So a parabola is just going to be all of the points that are an equal distance from a fixed point called the focus, which is this point right here, and a fixed line called the directrix. So it's kind of strange. It's a weird definition. It's not so nice like the one we did with the yarn and the two foci. Yes.
Is the focus the focus we've been finding, or just different than other way?
It's kind of like the focus that we've been finding. Yeah. So it's kind of like what we did with the ellipse equations and so on in the hyperbolas. Okay, so you have some different equations. There are lots of different standard forms for parabolas. I don't know why. I've looked in 3 different textbooks and they all have a different standard form. Okay, I'm going to make it very consistent with your Math Excel, and I'm going to use the thing that Math Excel uses to make it very consistent. Okay, in years past though, I've used a different formula, so that's led me to have a couple typos on these notes. So make sure you're paying attention, and if I tell you to correct something, correct something. Okay, so basically the first thing is going to be, if it's a horizontal parabola, it's going to look like y minus k squared equals 4p times x minus h. Okay, a horizontal parabola is going to look like this, or it will look like this. Okay, the one that opens to the right is going to be called, or it's going to happen when we have a positive p-value. And the one that opens to the left is going to happen when we have a negative p-value. It kind of has to do with like the reflections. Remember when we did our transformations and we had a negative, it flipped it the other way. So same thing for this. If I have x minus h squared equals 4p times y minus k, it's either going to open up and down, or up, or it's going to open down. So the up one is going to be when p is greater than 0, and the down one is going to be when p is less than 0. Okay, we will have lots of distances that are going to be important for us. As we are drawing a parabola, we will have the distance from the vertex to the directrix. That's going to be a length of p. And the distance from the focus to the directrix, or focus to the vertex, is going to be also a length of p. Okay, that's where the p number is coming into play. We're also going to talk about something that I will refer to as the focal width. The focal width is going to be the distance through the focus to both sides of the parabola. That distance will end up being 4p. So 4p equals the focal width. The old school word for this, which we no longer use because I teach high school students all day long and it's goofy, is the latus rectum. Gets giggles every time. Okay, so 4p is the focal width or the lattice rectum.
What is it actually called?
I have no idea.
This is just one random one.
I don't know. Is it the bottom of a parabola, I guess? The bottom? All right. Yes, Alex.
I think I know why.
I don't want to know why.
It's like a
Okay.
It's like a ladder, how it's flat.
A lattice is like a ladder?
It's like straight.
Okay. Okay, interesting. All right, so that 4p is going to help us when we're drawing our parabolas. It's just going to tell us how wide our parabola is. Okay, so the very first example. So it says, sketch a rough graph of the following parabolas. Determine the vertex, the focus, directrix, and axis of symmetry. We're also going to find the focal width. So I left that off. So on the very bottom, you can put focal width, and we'll have it on each example. Yes? Can't see it? Oh, from the slide? Is there a weird glare? All right, so nice. The vertex is just like the center of a circle. You remember how we found the center of a circle? It was like the HK thing, and that was the center of the ellipse, the hyperbolas, and so on. That's why we write it in this form. What's our HK in this example? Yeah, it's 4, comma, not 2. -2, right. So we're going to start there. So we're going to go over 4 and down to -2. It's very tiny. All right, now if I want the focus and the directrix, I first need to figure out what 4p is. 4p is always this number that is in front here, as long as it's in the standard form. So we'll talk about that. The standard form, as I was saying to the other classes, I always tell people that there's something on both sides. So there's a squared on one of the parentheses, and there's a number in front of one of the parentheses. You never have the square and the number on both sides. Okay, so each one gets their little flair. Okay, so we're going to have a square, and we're going to have the, do you guys see how the 8 isn't on the same side of this as the square? That's your 4p then. So 4p equals 8, so p is equal to 2. And I really don't worry about the sign of p. The sign kind of tells you which direction it's opening. But I just think about I'm moving up and down 2 or left and right 2. Okay. For this example, we have x minus 4, quantity squared. If I multiplied it all out, it would be something with x squared. Do you guys see how the y is not squared? It's just x squared. Okay. In chapter 5, we talked about parabolas already. If I have a x squared, it's an up and down parabola, right? Okay, which one is it? Does it go up or does it go down? It goes up. Why?
Because p is greater than
Yeah, exactly. The 8 was positive, so it's going to be an upwards parabola. So let's do a little rough sketch there so we know we're going to go up. So when we move our distance of 2, we're going to move up and down off of the vertex. So I'm going to go up 2, and I'm going to go down 2. One of those points that I drew in is going to be the focus. One of those points is not actually a point at all, but it's going to help me draw in the directrix. Okay, which one is the directrix? The bottom one, because the parabola is never going to cross a directrix. It always goes away from the directrix. Okay, it never goes like this. Like you're never going to cross. Okay, so the bottom one's the directrix. The parabola will always kind of go around the focus. Okay, so the focus is going to be here. The directrix is going to be this straight line right through here. If you want to label the other point as V for vertex, you could do that. All right, so that means that our focus is located at 4, 0, because we went up 2 from the vertex. The directrix is a horizontal line. How do I write a horizontal line? Is it x equals or is it y equals? What was it? It's y equals, right? Think about every single point on that line. This point right here would be 0, -4. This one's 1, -4, 2, -4, 3, -4. Do you see the thing that they all have in common is the y value? So the y is equal to -4. So y equals -4. And the axis of symmetry, that's the dotted line. That's kind of our fold line for a parabola. That's going to be an x equals in this case. So x is equal to 4. Okay, so we have almost all the information we need to sketch it in, but we really don't know how wide it is. You could try to estimate, and you could try to draw those little lines that I was drawing before, but that's kind of hard. So what we're going to do is we're going to find the focal width, so that way we can find 2 more points on our parabola. So the focal width is always equal to 4p. 4p is 8. It's basically just this number that was out front. So that means through my focus to the right and left sides of my parabola, I need to have a distance of 8. So I need to move to the right how much and to the left how much? 1, 2, 3, 4. Do you guys see it? Do you see how the total length between the two now? This length right here is 8. And we move right 4, left 4. All right, so when we sketch it in, we're starting from our vertex, we're going through there, and we just kind of extend it up. That is our parabola. Okay, it's always going to follow these steps. I will always have these steps written on your test for you, so you'll know kind of do this thing, this thing, this thing, and so on. The Directrix, that's what the other class was saying too. Like, why do we have that Directrix? It's because it's the one that's an equal distance from, you know, no matter where I'm drawing a point on the parabola. Do you guys see how it works? Those are equal distances. So it's kind of a cool line. Gives you a lot of, like, that's how you create a parabola, is through that line. That's how we came up with the equations. I won't bore you with all the math behind this equation, but it's pretty interesting. Yeah.
What do we use this for? Like,
oh, good question. I have a story problem at the very end of this section that is about parabolic microphones. Do you guys know what a parabolic microphone is? It is a microphone. That's basically, you use these at like sporting events. It's like a microphone. This is kind of what it looks like. I feel like headlights are parabolas too. I need to look into that. Okay, but anyway, so we have this, and it's kind of like a clear. If you've ever been to like the Colts game and you are lucky enough to sit close enough to see these, I'm never lucky enough to sit close enough, but I can see them on TV occasionally. It's kind of like on a big stick, and they've got like a little microphone thing in here. That's called the feed horn. You know what I'm talking about? It's my lovely drawing skills. Yeah, so that's a parabola. And basically what happens is the sound comes in, it bounces off the parabola, and it goes there. Right? So it's kind of magnifying the sound.
oh, that's pretty small.
Yeah, very smart. So anything that's involving like sound and stuff usually. Or lights, like I was saying, I think a headlight is a parabola too. I'll have to look at that. Okay. Next up. So we're going to do the same thing for this one. I want you to think about what direction this is opening. Okay, is it an x squared or is it a y squared equation? It is a y squared. So does it open horizontally or vertically? If it's a y squared is going to be horizontally. Is this one going to open to the right, which is positive, or to the left, which is negative? It's negative, so it's going to go to the left. That's right. So it's definitely opening to the left. Do you guys see how I went through that line of reasoning, I guess? Reasoning skills. All right, so where is my vertex? Be very careful. -2, comma, -1. Don't mix them up. And I don't have to write, like some people were saying, is it always going to be like the thing that's squared first? No, I could have written -12 times x plus 2 equals y plus 1 squared, right? I could switch them around, just make sure there's only like a certain amount of flavor on both ones, right? One gets the -12, one gets the 2. You're not going to have both on one side.
If we have both, we just write like.
Just divide it over, yeah. So like this next one has both. I'm tricking you on the next one. All right, so when I draw my point, -2, comma, -1. Since it's going to open towards the left, that's going to be my vertex, right? So you can kind of do a little rough sketch if you need to, lightly.
How do you figure out the left and right again?
I decided since it's a y squared, like if I multiplied it out, it's y squared. That means it opens to the left or to the right. And then since this was negative, then it's going to open to the left. Okay?
Yeah.
All right, so my focus and my directrix, they're going to be p units away. I need to find p. So I have -12. 4p equals -12, so p is -3. Now I'm not going to worry about the -3. I'm just going to kind of take the absolute value. That's how much I'm going to move right and left. It gets kind of confusing when students are like, do I move backwards -3? Like, I don't know. I don't like the double negative thing, so we're just going to say 3. So from this point, I'm going to move right 3, and I'm going to move left 3. One of those dots will help me draw on the directrix. One of those dots is going to be the focus. Which one is the focus? The left one, because the parabola has to go around the focus, just like I drew with that little feed horn thing, the little microphone. Okay? So the other line has to be your directrix. Oh, almost straight. Need a ruler. That directrix is an x equals equation because every single point on the line has the same x value. It's x equals 1. That focus is located at -1, 2, 3, 4, 5, -5. So it's going to be -5, comma, -1. What about the axis of symmetry? What's it going to be? No. Yeah. Y equals -1. I almost wrote -2. You got me confused now. All right, y equals -1. Remember, we're also going to find what's called the focal width. So it's going to be 12. That's correct. It's basically the number that's out front. Just don't worry about the positive or negative. So it's 12. So that means that I'm going to go up 6 and down 6 from my focus. So here's where my focus is. I'm going to go up 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. And here's my parabola. And that's it. It's really not too bad. Just a lot of steps. Yes?
Is it x equals 1 and y, so you're going to be the big cross the x on the y-axis?
No, it's just, you know, like if I ask you what's the equation of this vertical line that goes through the point 5, comma 0, right? It's x equals 5. That's what I'm doing. I'm just finding the equation of the vertical
For a
line.
second, I was like, I don't know.
Yeah, they're not always like opposite each other or anything. Okay, so the next one. So be careful. It says we need to get this in standard form. So this is not in standard form. How do we know it's not in standard form?
Because there's one more.
Yeah, there's the something with the squared is on the same side as the number, right? As Ed Henderson said in first period. He's in first period now. Doesn't that make you sad? He left your class. He said there's too much bling on one side. I like that. Too much bling. So there's too much bling. We need to get rid of some of that bling and bring it to the other side. So we have this -1/4. I'm going to multiply that -1/4 by -4 to get to the other side. So I'm going to rewrite. So I'm going to have x minus 4 squared equals -4 times parentheses y plus 2. And that's our standard form. Okay, which variable is being squared, the x or the y? The x. So when you have an equation that has x squared equals some kind of y, it's going to be a parabola that either goes up or down, just like those chapter 5 ones. Okay, so this one is either going to go up or down. Which one is it going to be? Down, because it's a negative. Good. Okay, they're on this. All right, my vertex is going to be at 4, comma, -2. Right, the HK. So I go 4, -2. All right, my 4p is equal to -4, so I get p equals -1. So I'm just going to say 1. All right, that's how much I'm going to move up and down because it's a downwards parabola, right? So I'm going to move up 1. Oh, it's very close. It's rough. Down 1. One of those points is going to make the directrix. One will be the focus. Which one's the focus? The bottom one. All right, the top one is my directrix. All right, now I need the focal width. Oh no, I skipped a lot of steps, didn't I? Man, I was just going for it. All right, so the focus is going to be, it was 4, comma, -2 for the vertex, so it's going to be 4, comma, -3, right? We went down 1 to get to the focus. The directrix was a y equals equation. In this case, it's y equals -1. What about the axis of symmetry? X equals 4. All right, so now our focal width. It's basically the absolute value of that number that was out front. So here's my number, -4. So it's going to be 4. It's 4p, basically. So I'm going to go over 1, 2, 3, 4. 1, 2, 3, 4. Oh, I lied. Man, I caught myself right in time. Someone was going to. Man, I go over 2, right? Oh, I'm still messing it up. I'm not putting it in the right spot. I need to enlarge this graph. I think that would help everyone, wouldn't it? It's very tiny. All right, so we're going to have that, and we're going to have that. Do you guys have it?
How far is it?
So you go right and left 2 from the focus. The Directrix, what is it? Yeah, the Directrix is, it's on the other side of the focus. So like, going from your vertex, on one side is the Directrix, on one side is the focus. Okay. Are you guys seeing how to graph them? Okay. So these are the ones that I just wasn't thinking when I made the problems. I did this all over the summer. You know, I update my notes every summer. And I put new problems in, and I put these in, and I just didn't think about them. Because I used to have, like going back to the main page, I used to write my standard form, not like this, but I would do like x minus h squared. I would divide by 4p, so it'd be 1 over 4p, and then I'd add the k over, so that way it was solved for y. Which in many ways, that equation is really nice. Like you can find the y-intercept pretty easily. So then you don't really need the focal width because you can still get like 2 other points on your graph. So there's many ways like this is easier, but I like that this one's kind of like what you've been doing with the ellipse and hyperbolas. You can easily identify HK, so I like that. And I also like that it's the same as what MathXL does. So anyway, so when I was making these problems, I didn't really think it through. And I made it so that when you complete the square on this, you get that p is very, very tiny. It's like 1 over 16. It's rough. So we're going to go with it on number 1, and then maybe part B, I'll have you guys write a new problem. All right, so 4a. So I have y equals 4x squared plus 8x minus 5. So I'm going to go ahead and I'm going to add the 5 over. Do you guys remember completing the square? In order to complete the square, we always need a 1x squared to complete the square. Okay, so what we do is we end up pulling out the 4 to the front. We factor the 4 to the front. So we're left with x squared plus 2x, and then we leave a little spot, a little box, right? Where we're going to put a number in. Is this looking familiar now? We did this just the other day with circles, right? Okay, so that means I'm going to have my y plus 5, and I'm going to have that little box. And sometimes I draw a little hat on that box, like a little house, and I put a 4 there. I've done that in the past, right? That 4 is coming from here. From the number right here. Okay, so in order to complete the square, I need to do my b divided by 2 squared. So I take 2 divided by 2, and I square it. So 1 squared is 1. That's going to be the number that I put in the box. But what I really added to this side of the equation wasn't just 1. I added 4 times 1, which is 4. So when I put a 1 on the left side, that's why I have that little house shape, right? The 4 times 1. Okay, you can do the house thing if you want, or you can just write plus 4. Doesn't matter. Okay, so I get y plus 5 plus 4 equals 4. And then when I factor x squared plus 2x plus 1, remember when I do the 2 sets of parentheses? I would end up getting x plus 1 times itself. So x plus 1 squared. So I get y plus 9 equals 4 times x plus 1 squared. Is it all the way in standard form? No. What do I still need to do? I need to divide it over, right? So I'm going to have 1/4 times y plus 9 equals x plus 1 squared. That's why I was saying I didn't really think this through. I didn't think, oh, when I divide that over, I'm going to get 1/4, not 4, like I was trying to get. Whoops. So what's your vertex? Yep, -1, -9. And then here's where it gets weird. Your 4p is equal to 1/4. So what's p? It is 1 over 16. You just know that because I told you already, don't you? You're just remembering. No. Didn't I tell you before we started? Your p is going to be 1 over 16.
Oh, yeah.
Oh, yeah. Yeah. I did say like. It's rough. I do all the time. It's because I was, you know, a 90s girl, and that's what we totally did. We said like and totally all the time. All right, here we go. I was really an 80s girl, but I'll say 90s girl just so I'm younger. All right, here we go. So here we go. So we have x equals, what if we have like negative 1 over 4 y squared minus 2y plus 3. So let's make that the new problem. So cross out what I just had for b and write that new one. So we're going to do the same thing, but let's do a more realistic p value. So the last one, like p being 1 over 16, that can happen. Don't be worried if that happens. It's just like when you do your vertex at negative 1,9, if I want to find my focus, I'm going to move down and up to get the focus in Directrix. I would move up 1 over 16, so it'd be kind of weird. It'd be like negative 9 plus 1 over 16. Well, what is that? You'd get common denominators. It would just be very tiny that you'd be moving. So that's why I didn't really like that last problem. Okay, so let's complete the square on this one. Okay, so we're going to have x equals, or sorry, I'm going to subtract my 3 over. So x minus 3 equals, and I'm going to pull out that negative 1/4 because I need a 1y squared. So I'm going to have a y squared plus something. What do I need? So if I multiply in here, what do I need to multiply by to get a negative 2y? Close. Positive 8. That is correct. So it needs to be an 8y. Do you see how you have a negative 1/4 already? So you need a positive. So close. All right, we're going to get something here, and we're going to add to this side as well. And you can do the little house thing if you want and put negative 1/4 in there. All right, what am I going to add inside the parentheses? Do your b over 2 squared. 16, right? Jenny said 16. So we're going to put a 16 here. What did I really add, though, to the whole side of the equation? 16 times a negative 1/4, right? So I get negative 4. That's right. So if you just want to do in the box negative 4, or you can do the little house thing if you really want. So what we get is x minus 7 equals negative 1/4 times, and when we factor, we have y plus 4 squared. So our last step is too much flare on both sides, right? So I'm going to multiply, or on one side. So I'm going to multiply by negative 4. So I get negative 4 times x minus 7 equals y plus 4 squared. So when I do that, what's my vertex? Seven, negative 4. When I set my 4p equal to negative 4, I get p equals negative 1. Now, I don't care on your test if you leave it as p equals negative 1, or if you guys want to say 1. Either way, it doesn't really matter. I consider both to be correct. It's just, like I said, it's really awkward when students are like, so I moved down negative 1. I'm like, wait, down 1 or down negative 1? Like, it's like a double negative in math. It's just weird. Okay? All right, the last one is talking about that parabolic microphone that I talked about. And it says that the equation is x equals 1 over 64 y squared. And x and y are in inches. How long does that microphone piece, the feed horn, have to be? So let's rewrite it. This is not in standard form. Do you guys see? Because the number and the squared are on one side. So I'm going to multiply by 64. So I get 64 times x equals y squared. So my 4p is equal to 64. P is equal to 16 then. So my vertex was located at 0, 0. Oops. And my focus is a distance of 16 away from it, right? So my feed horn is 16 inches. So that's what we're doing. We were finding the 16. You can think about it, it's a y squared equation. It would be like this, right? So it'd be 16 comma 0 if you want to actually write what the focus would be. Okay, does this all make sense? All right, so that's 8.4. Let me pass out your homework.